time. When you're diving, sometimes there just isn't enough of it. Somehow it seems like the better the dive, the sooner it ends. Much of diving's evolution has been a struggle for more time underwater. We use better and more effective exposure suits to help us stay comfortable longer. Dive computers give us far more no-stop dive time compared. And today, we can stay underwater even longer thanks to enriched air. Enriched air, sometimes called Nitrox, extends no-stop limits, and when coupled with an enriched air dive computer, provides more dive time than ever before. Enriched air is most useful in the 18-metre 60-foot to 30-metre 100-foot depth range, because in this range, the dive often ends because you run out of no decompression time. And you'll find enriched air really boosts your bottom time when you make repetitive dives. The PADI Enriched Air Diver course qualifies you to use Enriched Air Nitrox. You'll learn its benefits and drawbacks, special equipment considerations, the procedures for obtaining and analyzing enriched air, how to use enriched air computers and dive tables to plan dives, and how to effectively manage some of the possible risks associated with it. What exactly is enriched air nitrox? As you may recall, air consists of 21% oxygen and 79% nitrogen. Enriched air has been enriched with oxygen, so that it has more than 21%. Enriched air 36, for example, is 36% oxygen. As a recreational diver, you'll typically use enriched air that has between 22 and 40% oxygen. Most of what you learn in this course relates directly or indirectly to this added oxygen. The primary purpose of enriched air is to extend your no-stop dive time. As you recall, it's nitrogen dissolving into your body tissues that determines the no decompression limits. Enriched air replaces some of the nitrogen with oxygen, and your body metabolizes and absorbs oxygen. Since you're breathing less nitrogen, you can stay down longer, all else being the same, compared to the same diver using regular air. How much more no-stop bottom time you get depends upon your depth and the amount of oxygen in your enriched air blend. In the 15-metre 50-foot to 27-metre 90-foot range, the additional time can be substantial, especially on repetitive dives. When you use enriched air with an enriched air dive computer, your no-stop time is so long that you're more likely to be limited by your gas consumption than by reaching a no decompression limit. Sometimes divers wonder whether the no-stop limits for enriched air are as reliable as for air, and the answer is yes. Decades of tests and field experience with hundreds of thousands of dives by military, scientific, and recreational divers has established an excellent safety record for no-stop diving with enriched air. Sometimes divers wonder whether enriched air might have a safety advantage over air, or if it causes less narcosis. Diving well within air no-stop limits, there's probably no meaningful safety gain by using enriched air nitrox. And since oxygen has similar narcotic properties to nitrogen, plan your dive taking narcosis into account, just as you would with air. Enriched air does have 5 considerations you don't have diving with air within recreational limits. First, there's a potential for oxygen toxicity. This is the most serious of the potential hazards unique to enriched air diving. Second, you'll have a few special equipment considerations. Third, enriched air isn't as readily available as air. And fourth, enriched air requires special blending and handling protocols. Finally, you'll find that planning an enriched air dive takes a few more steps than an air dive, and there's a bit more error potential, though it's not particularly difficult. The primary concern about enriched air and your equipment is the high oxygen content in enriched air. In the presence of high oxygen, many materials will burn or explode that wouldn't otherwise. High oxygen can also make equipment deteriorate more rapidly over time. However, with enriched air that has no more than 40% oxygen, the community guideline is that you can use the same regulator, BCD, and other equipment that you use for air except for your cylinder. We'll look at cylinders in a moment. However, manufacturers, local laws and regulations, and local practices may require special equipment modifications for enriched air. A few manufacturers say not to use their equipment with enriched air at all. Follow the requirements that apply to your gear and your local area. Unlike your other equipment, enriched air diving requires a dedicated cylinder for 2 reasons. The first is that it must be clearly marked so no one accidentally dives with enriched air thinking it's air. The second is that one method of making enriched air involves putting pure oxygen in the cylinder. For safety, a cylinder used for blending gases this way needs to be specially cleaned and lubricated, even if the final blend will have less than 40% oxygen. Typically, an enriched air cylinder has a distinct color or band to clearly identify it. This type is the most common, but local regulations may stipulate other color coding. The cylinder will have a content sticker or tag that shows what enriched air is in it, a decal showing whether the cylinder meets oxygen service requirements, and an inspection sticker like you find on any other scuba cylinder. Filling your cylinder has some concerns too. The first is that high oxygen content can present a fire explosion hazard. And the second is that to dive it safely, you need to be certain of the percentage of oxygen in your enriched air. To manage these concerns, always have enriched air cylinders filled at a proper enriched air station by a qualified enriched air blender. Certified gas blenders have the special training and blending equipment necessary to avoid possible hazards related to oxygen. And they know how to blend accurately so you get the enriched air mix you want. This is especially important for enriched air cylinders that must meet oxygen service requirements for blending. Conventional air-fill systems may contaminate a cylinder with trace lubricants that are harmless with air but create a fire risk with oxygen. All gases put in the cylinder, including air, must be oxygen compatible. If an oxygen service-rated cylinder is accidentally filled from any source that doesn't provide oxygen-compatible gas or air, you need to have it reserviced before it can come in contact with any gas with more than 40% oxygen. This is why you would never put pure oxygen in a scuba cylinder and have it filled from a conventional air station in an attempt to make enriched air. Doing so poses a significant fire or explosion risk. Reputable blenders are trained and certified to avoid these problems. Look for the DSAT gas blender certification or other credentials showing training in gas blending. If you're interested in learning to blend enriched air Nitrox, ask your PADI instructor, dive center, or resort about the DSAT gas blender course. Diving air within recreational limits, your oxygen exposure isn't an issue. With enriched air's higher content, it is. As an enriched air diver, you need to stay within accepted oxygen limits and track your exposure, much as you do with nitrogen. You measure your oxygen exposure based on the oxygen partial pressure, which refers to the pressure exerted by just the oxygen in your enriched air. Find this by multiplying the oxygen percentage times the absolute pressure at depth in atmosphere or bar. For example, suppose you dive at 10 meters or 33 feet using enriched air 40. As you recall, at 10 meters 33 feet, the pressure is 2 atmospheres, one of air and one of water. 40% oxygen times 2 atmospheres equals 0.8 atmospheres of oxygen partial pressure. When working with percents, remember to use the decimal form, 0.40 in this example. Oxygen partial pressure will vary with your depth and the blend. Your oxygen partial pressure is 0.80 atmospheres absolute at 10 meters 33 feet, but with enriched air 36, you reach 0.80 atmospheres absolute at 12 meters 40 feet. Your oxygen exposure is the same. Oxygen limits are therefore independent of depth. The maximum oxygen partial pressure is 1.4 atmospheres absolute. You will learn to plan your dives so you don't exceed the blend's maximum depth, which is the depth it reaches 1.4 oxygen partial pressure. This is the accepted dive community standard, with a partial pressure of 1.6 atmospheres absolute, used as a contingency depth for planning purposes. You want to dive conservatively, well within the limits. Planning your dives so you remain well above the maximum depth where your blend reaches 1.4 oxygen partial pressure gives you room for error and an added margin of safety. By staying well within limits, you minimize the most serious risk in enriched air diving, oxygen toxicity. Exceeding 1.4 atmospheres absolute, partial pressure can cause central nervous system toxicity, which can manifest itself as a convulsion. While a convulsion isn't usually directly harmful, underwater, a diver is almost certain to lose his regulator and drown. Warning signs and symptoms may precede a convulsion, but usually they don't. If they do occur, they include visual disturbances, ears ringing, nausea, twitching or muscle spasms, especially in the face, irritability or anxiety, and dizziness. You can remember these by remembering vented. If you experience any of these symptoms, ascend and end the dive immediately. Heavy exertion, some drugs, and carbon dioxide retention may predispose a diver to oxygen toxicity. Avoid overexertion and breathe normally. Consult a physician knowledgeable in diving with respect to prescription medications before diving with them. Within the limits, enriched air diving has an excellent safety record, but ignoring the limits can be life-threatening. Remember, it's very easy to manage oxygen exposure simply by staying well within accepted limits. In Section 2, you'll learn more about tracking oxygen exposure, but for now, realize that not exceeding an oxygen partial pressure of 1.4 is the most important precaution you need to follow. By now, you realize that to plan your dives, you need to know the oxygen percentage of the enriched air you use. You use your oxygen percentage to set enriched air dive computers, to determine your no-stop limits, and to manage your oxygen exposure. Gas blenders analyze enriched air after mixing it using an oxygen analyzer. Nonetheless, you personally analyze the gas yourself, or in some cases, you watch someone analyze it while you personally confirm the analysis. Do not dive an enriched air cylinder unless you've personally verified the contents. There are no exceptions. Although errors are rare, this is an important double check of the initial analysis and that the cylinder's been marked correctly. Never forget that if there's an error, the person who can get hurt is the diver, you. Just as important, once you confirm the gas analysis, keep your cylinder somewhere that it won't accidentally be used by someone else or create any question about what's in it. If there's ever any doubt, reanalyze it. It's a good practice to reanalyze just before a dive in any case. Let's review the procedures for analyzing enriched air. You can use one of the many analyzers currently available to divers. Begin by turning it on and calibrating it. You usually do this by flowing air through the analyzer with a flow restrictor or other flow control device. Some of these connect your regulator's low pressure hose. Others attach directly to the valve. Use a slow controlled flow and set the analyzer for air, usually 20.8 to 21% oxygen, depending on the analyzer. After calibrating, leave the analyzer on and flow enriched air through it at about the same rate. Allow the reading to stabilize and read the oxygen percentage off the display. You can calibrate some analyzers using the air in the room, but don't do this in high humidity or when you've been analyzing a lot of cylinders, because these can affect the calibration. Your best bet is to calibrate with a cylinder of compressed air. Analyzers are reliable, but if there's ever any doubt, compare the one you're using with another. Your readings should be within less than 1% of each other. After analyzing, compare your analysis with the cylinder contents sticker or tag. Minor variations between the blender's analysis and yours are normal. But if you've already planned your dive and the blend is off by more than 1%, you need to recalculate your maximum depth and no stop limits if using tables, or reset an enriched air dive computer if you already set it. Most enriched air computers and tables use 1% increments, so round fractions to the closest whole percent. In this case, for instance, you'd set your enriched air dive computer for 36%. After confirming the oxygen content, check that the maximum depth for the blend is correct, or fill it in if it's blank, and that your name's on the cylinder. You'll finish by signing the Dive Operations Enriched Air Fill log, which usually lists the cylinder number, the gas blend, the maximum depth, and your name. If the operation brings the cylinders to you at the dive site, they'll bring a log sheet with them. After your dive, leave the contents sticker or tag in place. The blender uses it to confirm the residual blend inside. It's okay to write used or empty on it though. Although it's important to understand table use with enriched air, using enriched air dive computers is much more popular. Computers maximize your no-stop time, especially when multi-level diving. And most will warn you if you accidentally exceed the maximum or contingency depth for your gas blend. Most also calculate your oxygen exposure, as well as no-stop time, and warn you if you near the limits of either. Different models vary in how you set them, but with most, you enter a set mode and then scroll through the oxygen percentage until you find the blend you're using, then lock it in. If you forget to do this, most computers will go into an error mode. See the manufacturer instructions for the particular computer you're using, or ask your instructor. When diving with an enriched air computer, know the blend's maximum depth and stay shallower by following the depth display. Use the computer warning as a secondary alert. Dive conservatively, well within both the computer's no decompression and oxygen limits, and make safety stops. It's a good idea to back up your dive computer with the tables you'll learn to use in this course. And of course, each diver needs a personal computer. Don't try to dive sharing one. There are two considerations about enriched air nitrox and emergencies. What to do if a diver convulses underwater, and what to do for a suspected decompression illness for an enriched air diver. Although it's highly unlikely when staying within accepted oxygen limits, if a diver were to convulse underwater, handle the emergency just as you would any unresponsive diver accident. Hold the diver's mouthpiece in, if it's in place, and bring the diver to the surface. Establish buoyancy and check for breathing. Call for assistance and get the victim to safety, providing rescue breaths as needed. Once out of the water, continue to monitor breathing and circulation, providing CPR and rescue breaths as needed while waiting for emergency medical care to arrive. Some experts suggest holding the diver's mouthpiece in and waiting for the convulsion to subside before ascending. But the primary concern is getting the diver to the surface. If an enriched air diver is suspected of having decompression illness, provide first aid, including emergency oxygen, just as you would for an air diver. The oxygen exposure during the dive is not a concern. When there's enriched air at a dive site, you can provide it to a breathing diver if you run out of oxygen before help arrives. It may not be as helpful as pure oxygen, but it may help and certainly won't hurt. You can learn more about preventing and managing dive emergencies in the PADI Rescue Diver course and in the Emergency First Response, Primary and Secondary Care courses. Ask your instructor about these programs if you've yet to complete them. Section 2 of the PADI Enriched Air Diver course focuses on planning enriched air dives with the RDP, the Enriched Air RDPs, and the Equivalent Air Depth and Oxygen Exposure Table. You'll also learn a bit about using blends with more than 40% oxygen, and an overview of technical diving and how it relates to enriched air diving. Let's begin with how you'll use the standard RDP table for air with enriched air to find your no decompression limits, repetitive groups, and adjusted no decompression limits. Before we do though, let's look at how this video presentation helps you learn to use these tables. Each section covers concepts and general table use, but without detailed examples. Most people find specific table problems difficult and confusing to follow on video, leading to frustration rather than learning. So watch to learn the general concepts, then read your PADI Enriched Air Diver manual. The manual has specific examples that you can easily work through and follow at your own pace. Don't worry about memorizing everything while watching the video. That's not the purpose. Since the air RDP is based on breathing with air, to use it with enriched air, you will use an adjusted depth that accounts for your reduced depth. This is called an EAD, Equivalent Air Depth, which is shallower than the actual depth. You use the EAD to plan your dive in place of the actual depth. You find EADs for enriched air blends with 30 to 40% oxygen on the Equivalent Air Depth table. You find your planned actual depth in a column on the left, then find the EAD for it under the blend you're using. Use the EAD to find your no decompression limit on Table 1 of the RDP, and to find your repetitive group after the dive. Once you have your EAD, you simply use it in place of the actual depth. For a repetitive dive, continue through Table 2 to find your new pressure group after the surface interval, just as you've already learnt. When you get to Table 3, use the EAD of the blend you'll make the repetitive dive with for planning. Use the Equivalent Air Depth table to find the EAD for repetitive dives planned depth and blend. On Table 3, use the EAD to find your adjusted no decompression limit and residual nitrogen time. Remember that adjusted no decompression limits and residual nitrogen times are always based on the blend you're switching to. After running through the examples in the Enriched Air Diver manual, you'll find this fairly easy because you're using the RDP the same way you always have, except you use EADs in place of the actual depth for planning. But to make things even easier, there are two special RDPs, one for Enriched Air 32 and one for Enriched Air 36, which are the two most popular blends. You don't use EADs with these. Instead, you use them much like the Air RDP, except that you must be diving with Enriched Air 32 or 36 as appropriate, of course. The Enriched Air Rdp pressure groups are interchangeable with the Air Rdps, so you can switch to the Air Rdp with EADs, or from one Enriched Air Rdp to the other, if you switch blends for a repetitive dive. Remember that you switch as you enter Table 3, and use the EAD or Enriched Air Rdp for the blend you are switching to. Go through the examples in the PADI Enriched Air Diver manual, and you'll find this straightforward. Earlier, you learned that to control your oxygen exposure, you need to plan your dive so you don't exceed the depth at which the blend you're using reaches 1.4 oxygen partial pressure. The horizontal line on the Equivalent Air Depth table corresponds with the maximum depth for each blend. You find the EAD immediately above the line and the corresponding actual depth on the left side of the table. This is the maximum depth with that blend. Below the line, find the last EAD listed and the corresponding actual depth on the left. This is the contingency depth for emergency planning only. The Equivalent Air Depth table also shows you the oxygen partial pressure for each depth and blend. Notice that the oxygen partial pressure for the maximum depth is near but not over 1.4, and for the contingency depth, near but not over 1.6. You will also use the oxygen partial pressure to keep your oxygen exposure within 24 hours within limits. To do this, you find the oxygen partial pressure for the dive depth and blend the same way you find the EAD. Take the oxygen partial pressure to the oxygen exposure table and find it on the top. Round to the next higher one if the exact partial pressure isn't listed. Under the oxygen partial pressure, find your dive time, again rounding up to the next greater time if the exact time isn't there. Then, find the oxygen exposure percent on the right. This is how much of your allowable exposure you've used for that dive. When making multiple dives, you add the exposures for each dive, making sure you don't exceed 100% in 24 hours. In practice, you'll find you can dive quite a bit and still be well within oxygen exposure limits, especially if you keep your oxygen partial pressure well below 1.4. Being conservative, it's recommended you stay within 90%, and if you exceed 50%, allow at least 1 hour between dives. If you accidentally exceed 1.6 atmospheres absolute, your oxygen exposure is 100% and you should not dive for at least 12 hours. In planning your dives, use the Equivalent Air Depth table, RDPs, and oxygen exposure table to determine your allowable no-stop time and your allowable oxygen exposure remaining. Remember, your allowable dive time is always whichever is shorter. You'll find this simple after some practice with the examples in the PADI Enriched Air Diver manual. And use the manual if you get rusty and need to review table use. As a recreational diver, most of your enriched air nitrox dives will be made within 30 to 40% oxygen. Recreational divers seldom use blends with higher oxygen content. But an exception is when diving with recreational semi-closed circuit rebreathers.